All right, Graham. So Graham is walking 8 blocks from his home to the library. So if we draw the grid here, this is Graham's house over here. We got the library down here. And he is walking 4 blocks east and 4 blocks south to get to the library. Are you okay with this? Nice. I'm going to lock that. Perfect. No? There we go. Because then I think I can draw on it. Yeah, and the green doesn't erase. Perfect. Okay. So one possibility is Graham could go straight 4 blocks east, straight 4 blocks south. That would be one. Okay? I'm going to draw some other possibilities here. Okay? And this would be one, this is not a good strategy, but I'm going to draw them, you count them, and you tell me if I ever repeat. Ready? Okay, so we did one, there's one, here's another one, there's another one, count them up. You could go this way, you could go all the way this way, you could go that way, this way, that way, that way. And we're assuming Graham is a smart guy, that Graham is not going to get confused along his path and loop around this block infinitely. Okay, so he is always going to get closer to his destination. Yeah, the loopy one, we can count the loopy one. But did we count this one already? Yeah. Yeah? How about this one? Okay, how about this one? Yeah? How about this one? Ooh, okay. So is this a good strategy, or are we going to get confused? Are we going to miss one? Probably. Okay. So how do we recognize that this is a Mississippi question? It doesn't look like a Mississippi question. It looks like Graham is going to the library. Well, if we represent it with letters, each path that Graham goes will have 4 easts and 4 souths. Right? So that would be one way that he could go there. And that path would be this one. East, 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 south, 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 south. Right? Now Graham, being the smart guy that he is, probably chooses this path all the time because it's easy. Oh, that's pretty bad, eh? So that would be east, east, south, 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 east, east. Now, every time I make a new arrangement of easts and souths, I'll get a new path. And an arrangement of those easts and souths is like Mississippi. Normally, it would be 8 factorial if every direction was different. But we have repetition, identical objects, 4 E's and 4 S's. And so there are 8 factorial divided by 4 factorial, 4 factorial. Type that into your calculator and you'll get 70. So one way of figuring out pathway question like this is to think of those identical objects as identical routes and count it that way. Now another way is to systematically count as Graham goes to the library. So first of all, if he wanted to get to this intersection, and again, we're going to assume that he's smart, he's not going to backtrack. How many ways could he get to this intersection here? One way. There's just the one path. Similarly, there's just one way to get to that one. How many ways could he get to this one? How many paths are there? Still only one, right? Just that straight path is the only way to get there. And there's only one way to get to there and one way to get to there. One way to get to this one way to get to this one way to get to the corner. Because the only path to get to the corner is the straight one. How many ways could he get to this point? 2. We could draw them in. There's this way 1, this way 2. So there's going to be 2 ways to get to that one. What about this one? So let's draw them out. 2, 1, 2. Is there any other ways? Could also go that way, 3. So there's 3 ways to get to that one. By symmetry, there's 3 ways to get to this one. Now I want you to look for a pattern. The next 3 numbers along the diagonal here, there's 4 ways to get here. There's going to be 4 ways to get here. There's going to be 6 ways to get to that one. How can we figure out the next numbers? What do you think this is going to be? 5, easy pattern, 1, 2, 3, 4, 5, not bad. What about this one? It's going to be 10. Now, the way that we can figure out that this is 10 is to say, well, if Graham can go 4 ways here and 6 ways here, he can get to this one either by these 6 ways or those 4 ways, making 10 ways in total that he could get to that one. Similarly, there'll be 10 here, and then we can fill out the rest of these numbers quickly. 15, 20, 15, 35, 35, and 70, same number that we had before. So we can also count the pathways as we go. Now, the pathways counting method is really nice, especially sometimes I've seen on questions where they've added new situations, right? Like right here is where Susie lives. And all of a sudden, every time Graham goes to the library, he happens to walk by Susie's house. Now, how many ways can Graham get to the library? Can you see that in this situation, this no longer becomes part of the, we're really only looking at this grid here and this grid here. Because Graham is always walking by Susie's place. So if we erase this up, put Susie's house back on there, and start counting, well, I'll just put dots on the ones we need to figure out. Those are the places that Graham could visit on his way to the library. Again, these are going to all be 1s across here. Agreed? And how many are going to go here? 2, 3, 3, 6, 10. So there's 10 ways to get to Susie's house. How many ways to this point right there? How many ways to this one here? 0, because he doesn't go there, right? So then how many ways to this one here? Still 10. Because he can go to Susie's house, and then there's only 1 route there, but it's not a new route. Still 10, and these ones here will still be 10 as well. This will be 20. And this is 30. So now he's got quite a few less routes on the way to the library, because he had 70 ways before, and now it's down to 30. But it's worth it. Okay. Questions for this one? Number 12.